Good morning, everyone. How you doing? We're going to be taking a look at the next part of our algebra journey. This is section 9.5, and it's a quadratic equation. Some people would consider this section right here to be like the ultimate goal of Algebra 1. I know when I was in school, I thought that this is where we were heading the entire time with Algebra 1, is learning how to solve this kind of quadratic equation using this formula. And it's a very powerful formula. A lot of people tend to forget about it and move on or even regress back to using things like factoring. But with the quadratic formula, you can pretty much solve any quadratic equation just by plugging in a few numbers and doing a little bit of mathematics. So let's take a look at this, how this gets started. So what we have here is this long solve, and you're noticing that we start off with a regular, how do we call this? A regular quadratic equation, okay? Right over here, ax squared plus bx equals c. So we're going to attempt to solve this just by using some subtraction. I think we're going to be completing the square here. So if you take a look at what happens, what did we do to get from this step to this step? And the way I'm looking at it is, just take a look at here at c, and look over here, you got 4ac. So it seems to me as though we are multiplying everything by 4a. So if we multiply everything by 4a, this first term here used to be ax squared, and now if I multiply that by 4a, I get 4a squared x squared. So it kind of checks out. I know I didn't check that linear term, but it will check out. Let's compare step 2 and step 3. In step 2, you get yourself a 0 on the right side, but on the left side you get a b squared. Notice that on the left side there's also a b squared. So it seems as though we're adding a b squared to both sides of our equation. So we add b squared to both sides of our equation. Question 4, well, what's the difference? I notice that the minus 4ac is over here, and this side doesn't have a 4ac anymore, and it used to have one here. So it looks like we took this 4ac and we subtracted it and put it on the right side. So we subtracted 4ac from both sides of our equation. Okay, now that I've subtracted 4ac, going from here to here, there's no difference. But on the left side, there is a difference. No doubt you'll see the parentheses there, which is pretty much indicative that we factored. So is this a perfect square? Let me see. The square root of 4a squared x squared is 2ax. The square root of b squared is b. And this is 4abx, which is 2ax times b times 2. So yeah, this is just a factoring. So this is completing the square, isn't it? We've added that b squared, and that helped us complete the square. And now, to get from here to here, I notice that the right side shows up in a square root. The left side is no longer in a square. So I just square rooted both sides. That's what happened. And then to get from step 6 to step 7, I notice that the b shows up from the left to the right. So I think we're just subtracting a b from both sides. So we subtract a b. Finally, 2ax to x, a squared, and there's nothing under there. So it looks as though we're dividing both sides by 2a. So divide both sides by 2a. And what you get left with is something called the quadratic formula. And this is the first time of about 5 times they're going to say that you need to memorize this. Okay. Very important to memorize this. Okay, so that's our quadratic formula. That's the one you're going to have to remember. There are tons of ways to memorize it. I know that if you just Google quadratic equation song, YouTube quadratic equation song, you're going to find tons and tons of material. The most popular one that most people do and the most earworming one is that one that's to Pop Goes the Weasel. So look for the quadratic equation song so you can memorize this using a wonderful song. Now this is the way that I learned how to solve the quadratic, or how to come up with a quadratic formula, and that's by completing the square. So what do we do when we complete the square? Well, there are a couple hints here, but I'll just tell you what I did. The first thing that you're going to do is subtract c from both sides. You'll notice that I've done this like I always do in red. And when you subtract c from both sides, you get ax squared plus bx minus c. Next is to divide everything by a. When I'm completing this square, I do not want a coefficient for x squared. And that gives me ax squared over b over ax. Let me start that over again. That gives me x squared plus b over ax equal to negative c over a. Cool. Now I'm ready to complete the square. This does look kind of gnarly, I admit, but you know, math is not always for the weak of heart. So if I want to complete the square, the first thing I do is divide the linear coefficient by 2. That gives me b over 2a. And then I square that, so that's b squared over 4a squared. So I'm going to add b squared over 4a squared to both sides of the equation here. And that gives me this, x squared plus b over ax plus b squared over 4a squared. There should be a square there. Let's write that. Okay. And that's going to be equal to b squared minus 4ac over 4a squared. Cool. Now the nice part here is you don't actually have to factor the left. Remember, it's just going to be x plus b over 2a, quantity squared. X plus b over 2a quantity squared equals b squared minus 4ac over 4a squared. Square root both sides. Okay, here's me square rooting. And you get x plus b over 2a equals plus and minus b squared minus 4ac over 4a squared. On that right side, 4a squared is a perfect square, so I'm going to elect to do the numerator and denominator square roots separately. So that gives me, what is that, x plus b over 2a equals square x plus or minus b squared minus 4ac over 2a. And boy, you're lucky you don't have to reproduce this on your own. Next, subtract b over 2a from both sides, and that's really going to finish it off. So if I subtract b over 2a from both sides, I get this equation right here, which is negative b plus or minus the square root of b squared minus 4ac over 2a. I'm not going to sing it for you. That's that same formula. You have to memorize that. Okay, memorize. Got it? So, coffee break. Compare this method with the method in Exploration 1. Explain why you think 4a and b squared were chosen. Well, first of all, which of those two methods did you prefer? I know I prefer the second one that we did, mostly because I'm familiar with it. But you might prefer the first one. No problem. And the whole reason why we chose these quantities to add was because we were completing a square. So we needed to create perfect squares in order to factor. Which leads us to question 3. How can you derive a formula that can be used to write the solution for any quadratic equation? And I choose to complete the square using ax squared plus bx plus c. That way, no matter what the quadratic equation is, as long as you can write it in standard form and you know what a is, what b is, and what c is, you can solve using a simple formula, which if you are going to be a computer programmer, this is something that which you can memorize. We like formulas in this field of computer science because formulas are easy to program. So we can program this on a computer if we ever needed to solve things. Now this next set of 3 questions, while they are a little bit of practice on using the quadratic formula, the real reason why we're doing them is we want to make this idea of the discriminant and what the discriminant means. So we'll talk about what the discriminant is as we do these problems. And I'll try to give you my recommended method for using the quadratic formula for you all. Of course, it starts with memorizing. And the second thing to do is make sure you're in standard form. So let's take a look at A. Is everything equal to 0? Yes, it is. Actually, I can take a look at A, B, and C right now and see that they're all in standard form. Ax squared plus bx plus c equals 0. Remember that the quadratic formula only works on things that are in standard form. So for question 4, what is A, what is B, what is C? And as you can see, A is 1, B is 2, and C is -3. Now that I've done that, this is where I differ from a lot of math teachers. The first thing that I want you to do is figure out the value of what we call the discriminant. The discriminant is b squared minus 4ac. That's the part that's inside the square root. And the reason why I want you to do that now is because it's a lot easier to do it. You get a lot less confused if you figure out the discriminant before you even start with the formula. So b squared minus 4ac, that's the same thing as 4 plus 12, which is 16. Great. So now whenever I need b squared minus 4ac, I'm going to use a 16. The other part of this exercise that's supposed to be important to you is 16 is a positive number. And we'll take a look at why that's important. Hint, it has to do with the square root. All right, so next, write down the quadratic formula. X equals -b plus or minus b squared minus 4ac over 2a. Substitute the numbers. B is 2. The discriminant is 16. Notice I don't have to do any math inside the square root. I'm just putting in that 16 because I figured that out early. Over 2 times 1. If you're really on top of things, I don't even bother with 2 times 1. You know, calculate that 2 times 1 is 2 and put a 2 on the denominator right now. Now that you've done all of that, you are going to just simplify things. This is -2 plus or minus 4. Remember, 4 is the square root of 16 over 2. And remember, this is 2 answers. Your first answer, x equals -4 minus 2 over 2, which is -3. And your second answer is x equals -2 plus 4 over 2, which is 1. Whew. That's what it looks like when things go well. Letter B is also an example of things that are going to go well. Maybe you might think that they're going to go better than part A. And I don't know why, but when I did it this time, I didn't bother with a discriminant just to kind of show you how this kind of gets all jumbled up. So I'm going to start with a quadratic formula, and then I'm going to put all the numbers in there now. When you put all the numbers, look how ugly that looks. You know, compare that to over here, this step and this step. Which one of those two things looks cleaner? I bet I know. I have an idea about which one of those two things are cleaner. But now we've got to simplify inside the square root, which can be confusing. So what is that? 16 minus 4 times 4. So 16 minus 16. Got off easy this time, which is 0. So the answer is just 4 over 2. Notice what happened with this problem. The discriminant was 0. And we only have one answer, and that's x equals 2. So if for letter A we have a positive value in the discriminant, for letter B you get 0 in the discriminant. Any guesses what's going to happen with C? Let's figure this out. A, B, and C. The discriminant is 16 minus 20, which is negative 4. If you said negative number, you were right. Okay. Let's put the quadratic formula. Substitute numbers, and notice what happens there. I highlighted it even. You got a square root of a negative 4. And the square root of negative 4 doesn't exist. Okay. Therefore, when the discriminant is negative, you get no solution. Okay. Visually, we'll see what that means in a minute. Number 5, use the internet to search imaginary numbers. You can go ahead and do that. I'll wait for a second. Okay, so to make this a long story short, an imaginary is what happens when you take a square root of a negative number. Now, I know I just said it doesn't exist, and it doesn't exist, but mathematicians often find it useful if we pretend that it does exist and say that the solution is something that we call an imaginary number. So the square root of negative 4 is imaginary. When you get to Algebra 2, you're going to deal with imaginary numbers a lot more than what we've touched on here. In fact, we're going to stop with imaginary numbers and just say that whenever you take the square root of a negative number, you get no solution. A little bit of note-taking for you. We've got the quadratic formula, and the quadratic formula is a method of solving quadratic equations. I don't want to say that it's better than the methods that we've come up with so far, but it definitely is versatile. You can use it in any situation as long as you have a quadratic equation that is in standard form. What is the discriminant? The discriminant as an equation is b squared minus 4ac. As a concept, the discriminant is the radicand of the quadratic formula. Okay. Core concepts and the real solutions are given by the quadratic formula. Remember, I said to memorize that. That is negative b plus or minus b square root of b squared minus 4ac over 2a. Interpreting the discriminant. Let's take a look at what happens in this very first one. You got b squared minus 4ac is greater than 0. Greater than 0 means we have a positive result. And notice what happens when you graph something with a positive discriminant. Your parabola is going to go through the x-axis in 2 different places. Okay. And should that happen, that means you're going to have 2 x-intercepts. And an x-intercept is the same thing as a solution. So a positive discriminant means 2 solutions. A 0 discriminant means that you have precisely 1 solution, 1 x-intercept. And that's what happens when the vertex is right on the x-axis. And if you take a look at that third one, you know, that's the most fascinating one of them all from a certain point of view. In that one, the parabola doesn't even touch the x-axis, so there are no solutions. So this is what a graph of a quadratic equation looks like when you have a negative discriminant. It doesn't touch the x-axis. It's either entirely floating above the x-axis or floating below the x-axis. Here's a quick summary of all the methods that we have already figured out, and this is really the end of our methods for solving quadratic equations. You have, I count, 1, 2, 3, 4, 5 different ways of doing it. Okay, if we can show you 5 ways of doing the same task, and you choose not to figure out at least one of them, you know, what are we doing here, folks? You gotta master at least one of these, okay? First way of solving a quadratic equation, that's factoring. Factor it, use your easy maths, and then you got an answer. Straightforward, that's say advantage. Disadvantage is you will find equations that are not factorable, so you can't even factor every equation. The second way of doing this, of solving a quadratic equation, is graphing. Okay? And this is really easy, especially if you know your friend Desmos really well. And a disadvantage is if you're not using something like Desmos, then you may not get the exact solution. So using technology, a lot of people think that graphing is the best way to solve any equation, especially if you can graph things really quickly and cheaply with something called like Desmos. Or if you have a TI-80 calculator, TI-84, TI-89, one of those calculators will allow you to graph and solve really easily. Third method is using square roots. Now that's not used for every equation. It's only used if you have x squared equals a number. If x squared isn't equal to a number, then you can't really use a method of square roots, in which case you would have to go by completing the square. Now, completing the square may involve difficult calculations. Well, I don't know about that. Well, of course, that's me, your algebra teacher, saying that. But it's best used when a is equal to 1 and b is an even number. If you're thinking about completing the square and a is not 1 or b is perhaps odd, you may want to think about using what we just learned, which is a quadratic formula. So the quadratic formula can be used for any quadratic equation. It gives you the exact solution, but the only downside is it takes some time to do the calculations. If it was me and someone said, hey buddy, solve this quadratic equation, I'd probably graph it on Desmos, because that is the easiest way to solve a quadratic equation now that we have a lot of technology accessible at our fingertips. We're going to do some example problems now, starting with question 2. First thing that you do with any of these is to, if you've set yourself on using the quadratic formula, make sure that you're in standard form. This is in standard form. I've got ax squared plus bx plus c equals 0. And then I'm going to write down ABC. 1 is for a, 2 for b, and negative 8 for c. The next step is to figure out the value of the discriminant. So what is the discriminant? Discriminant, you will remember, is b squared minus 4ac, which would give me 2 squared minus 4 times 1 times negative 8. That negative 8 looks really ugly. Sorry about that. And that is 4 plus 32, which is just 36. Some people like to square root that now. I'm not going to bother with that square rooting. We'll do that later. The nice thing about doing the discriminant first is you also know if you don't have to waste your time with this question, because if I had gotten a negative discriminant, I would stop working and write down the words no solution. So that is one advantage to using the discriminant early. Now that I have the discriminant, write down the quadratic formula, substitute in numbers. Notice that the discriminant, I just put the 36 in there. I didn't bother doing b squared minus 4ac because I already did it. Alternatively, the denominator, I put 2 times 1, and if you can, in your head, quickly say that that's equal to 2, just stick a 2 down there. And then simplify. Notice that the square root of 36 is just 6. So this is negative 2 plus or minus 6 over 2. Now we're going to separate out into the two solutions. First solution, x equals negative 2 minus 6 over 2. Negative 2 minus 6 is negative 8. Negative 8 divided by 2 is negative 4. And then the second solution, negative 2 plus 6 over 2, which is just equal to 2. And you're done. Next, I want to take a look at question 4. And the reason why I want to do question 4 in particular is you will notice that this is not in standard form. You've got an equation that's equal to negative 13. So in order for us to even begin here, we've got to put this in standard form. And you're going to do that by adding 13 to both sides of the equal sign. That gives me x squared plus 6x plus 13 equals 0. Having done that, we're in standard form. Let's figure out a, b, and c. And now that I have a, b, and c, calculate the value of the discriminant. So the discriminant is b squared minus 4ac, which is 6 squared minus 4 times 1 times 13, which is 36 minus 52, which is, oh my gosh, that's negative 16. The discriminant is negative. What did I say to do if the discriminant is negative? Stop working. The answer here is no solution. Now with question 6, we're going to see how things can get really frustrating. There's a lot of work we need to do before we even can start with the quadratic formula. And taking a look at this equation for question 6, the first thing I notice is that, well, we're not in standard form because we have a 6 on the right side. So we're going to subtract that 6 from both sides of the equal sign. Okay, that was nice. That gave me negative 4x squared plus 8x plus 6. The next thing I decided was that, hey, I don't like having a as negative 4. So one thing you can do to make things equivalent and yet make a positive is just to multiply both sides of the equal sign by negative 1. This is virtually cost-free since you're on the right side multiplying 0 times negative 1, which is still going to stay 0. So you now have, what is this? 4x squared minus 8x minus 6 equals 0. And then the next thing I noticed was, which I probably should have noticed earlier, is that all the numbers here are even. So it would be easier if I decided to divide everything by 2. That's going to create an equivalent equation and with smaller values to work with. So now that I have this, the smallest possible values of a, b, and c, a is greater than 0, now I'm going to begin to work. So you notice all of that stuff that happened before we even officially started the quadratic equation is just to make the quadratic equation go a little bit smoother. So first, a, b, and c, of course. Next, let's figure out the value of the discriminant, b squared minus 4ac. That's negative 4 squared minus 4 times 2 times negative 3. Do all the multiplication, 16 plus 24. 16 plus 24 is 40. That's a positive result. So I know I have two solutions to this problem. Okay, discriminant had, let's write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Why did I sing that to you? I don't know, but whenever I even say it, that song is in my head. Substitute. Okay, you'll again notice that instead of b squared minus 4ac, I just shoved in the 40 because I already did that calculation earlier. Likewise, if you are strong-minded enough and you know that 2 times 2 is 4, your denominator, you could just put a 4 there right now, and I would be very happy if you did. Okay, simplify. You got a negative 4, and that's just the same thing as positive 4. Notice that that square root of 40, I kind of separated that into 4 times 10 because I know that the square root of 40 is, well, you can simplify that. That's the square root of 4 times the square root of 10, which is 2 square root 10. And then the next thing I noticed is 4, 2, and 2 are all divisible by 2. So I'm just going to divide everything by 2. And I get 2 plus or minus root 10 over 2. That is actually the answer. There's no more dividing to do. The square root of 10 is not, it's not an integer. It's what we would call irrational. But you can use a calculator to figure out what that is if you wanted to. Let's see. Let's take a calculator out and figure that out. First of all, the square root of 10 is 3 where did that go? 3.16. So then the quadratic solution here becomes 2 plus or minus 3.16 over 2. 2 minus 3.16 over 2, which 1.16 over 2 is 0.58. The second solution of this, you're going to take instead of 2 minus 3.16, you're going to get 2 plus 3.16. And then 2 plus 3.16 is 5.16, so 5.16 over 2, which is 2.58. So the solution to question, what is this, 6, is x is about equal to 0.58. And x is also about equal to 2.58. Okay. Now, I agree with you. Question 6 was a pretty intense problem. There are definitely places where you can shortcut things around if you were mathematically sound. I wouldn't recommend so many shortcuts if you're not too mathematically sound. But here is our classic quadratic formula. Moving on to our word problem, question 7. We've got a square pool with a side length of x feet. A uniform border around the pool is going to be 1 foot wide. And then the total area of the pool is going to be 361 feet. Sorry, the area of the pool and the border. You know, when I was a kid, we called that the deck. But okay, we'll call it the border. Okay, so what is the area of just the pool? Notice that the pool is a square x by x. So when I want to find the area of the pool, I just have to figure out x times x. The area of a square is a side squared. So I think we should draw the situation. Starting with, what does the pool look like? Well, the pool, which I tastefully did in blue for you, is x times x as a square. The border, which I'm going to pretend it's concrete because that's the way my pool looked when I was a kid. The concrete border around the pool is, well, notice that it's 1 foot on every side. So this part right here, let me draw for you. This part right here, that's 1 foot, and this is 1 foot. So this entire length here is 1 plus x plus 1. So that is x plus 1, which is x plus 2. And the other dimension, you got 1 plus x plus another 1. And that's going to be x plus 2 as well. X plus 1 plus 1, x plus 1 plus 1. So the area of the pool and the deck is x plus 2 times x plus 2, which is the same thing as 361, because notice they gave me a numerical value for the area of the pool and the border. So that's equal to 361. We're going to solve this for x, which means that we're going to have to get this in standard form. That's always job 1. Get this guy into standard form. So it's not in standard form. You're going to have to expand the left side, x squared plus 4x plus 4 equals 361. And then you're going to subtract 361 from both sides. Simplify. And you get x squared plus 4x minus 357 equals 0. Values of a, b, and c are 1, 4, and negative 3, 57. Just like I did last time, I'm going to figure out the value of the discriminant. So the discriminant is b squared minus 4ac, which is 4 squared minus 4 times 1 times negative 357. Those are really big numbers, which is 16 plus 1,428, or just 1,444. Maybe I should say that as 1,444. All right, that's a positive discriminant, so I know I'm going to have two solutions, one positive, one negative solution. Let's figure out what they are. Well, maybe not one positive, one negative, but if I did get a negative solution, I know that that can't be the correct answer. Since we're talking about the length of a pool, I've never seen a pool with a negative length. So here's our quadratic formula. And we're going to substitute numbers in. Just like before, I'm not substituting b squared minus 4ac. I'm substituting the value of the discriminant. Just like I've been saying this entire time, if you're comfortable, that denominator there, you can just make that a 2 right off the beginning, so you don't have to do, you can do a little bit less math. A little bit of math in the head means a little less math a little further down the line. Okay, so the square root of 1,444 is 38. I noticed that I forgot to put a 4 there. So just taking a look at that, I can see that one of those roots are going to be negative. One of those solutions is negative. Which one is it? Well, minus 4 minus 38 is negative 21. This can't be a solution to our problem because that's a negative result. Okay, the side of the pool has to be a positive number. The other solution would be negative 4 plus 38, and that gives us negative 4 plus 38 over 2, and that's positive 17. So the area of the pool is 17 squared, which is 289. Okay, 289. Not that bad. I like how this question mathematically is easier than the previous one that we just did, but it is in word problem form, so you better learn how to read. Questions 8 through 10 say to find the number of solutions, and I get happy when I read that number of solutions because all they really want to know is what's the discriminant and what can you tell based on the discriminant. So question 9. The discriminant is, well, first of all, a, b, and c, 1, 6, and 9. The discriminant is b squared minus 4ac, which is 36 minus 4 times 1 times 9. Notice that in my math, I already knew that 6 squared was 36, so I just wrote it down there. Certainly that's taking a little bit of a shortcut, and I would only encourage you to do that if you are rock solid on your math. 36 minus 36 is 0. What does it mean when the discriminant is 0? Well, that means that there's only one solution. Hello, one solution. Okay, so that's that. I better write down the words one solution over there. Moving on to the next set of questions, you've got what's the number of x-intercepts? And when I see that, again, very happy because the number of x-intercepts is just the same thing as the number of real solutions, which is related to the discriminant. All you need to do here is calculate the value of the discriminant and figure out or analyze based on that number. Noticing that this is already in standard form, but it's not equal to 0, so I'm going to make it equal to 0. Logically, that means you're saying the y-coordinate is 0, which is the same thing as an x-intercept anyways. Okay, a, b, and c, negative 1, negative 8, negative 18. Or if you like, you could have multiplied by negative 1. But in this case, since I'm just doing the discriminant, I'm not going to bother with that step. Okay. Discriminant is b squared minus 4ac. Substitute numbers, that's negative 8 squared minus 4 times negative 1 times negative 18. That's 64 minus 72, which is negative 8, which, hey, negative 8, that's less than 0. So no solutions, no x-intercepts. Remember, solutions and x-intercepts are the same thing. So if you answer one question, you're answering the other as well. Numbers 14 through 16 is free solve. You can solve using any method you want. Since we're learning about the quadratic formula, I figured I'd pick number 16. Since 16 is probably the one you're going to want to do with a quadratic formula, since a is equal to 3 and b is equal to 1. So those are both of the two things that we look out for when we use a quadratic formula. So we are in standard form with question 16, so we figure out a, b, and c. And as is my custom, I'll figure out the discriminant first. That is 1 squared minus 4 times 3 times negative 5. That gives me 61, which is not a nice number. It's not a perfect square. All right, the quadratic formula, of course, and substitute the numbers. This is the last time I get to say it, but if you are comfortable, instead of writing 2 times 3 down there, if you are comfortable writing a 6, I applaud you. Okay. Simplify that. That's negative 1 plus 7.81. You might ask where 7.81 came from, and 7.81 is the square root of 61. So I already made up my mind that I'm going to be estimating here. I'm going to be getting a decimal approximation. So I'm putting a 7.81 already. Let's figure out our two solutions. The first one is negative 1 minus 7.81 divided by 6. That's negative 1.47. And then negative 1 plus 7.81 over 6. That's x equals 1.14. And that's it, everyone. That was a long one. I'm looking at the clock right now, and that says 42 minutes. I can't believe we've been at this for 42 minutes. But this is a pretty intense lesson. So have fun with the quadratic equation. Listen to the quadratic equation song a few times. Figure it out, and then I will see you guys next time.